Hello everyone and welcome to today's video. We'll be starting this course with a short introduction into a number of topics, and the first one is a very brief introduction into propositional logic. So our first topic today is introduction. Propositional logic. Now, the idea here is that in mathematics, we often want to formulate statements and then say something about whether a statement is true and under which conditions a statement is true or not. There is some formalism involved with that, and today we are going to briefly discuss this formalism and introduce the most important notation. You will probably be familiar with most of that already, so just treat that as a brief recap of what you hopefully already know. Let's start with the basics. So we'll say a proposition is some statement that may either be true or false. That doesn't mean that we would have to decide whether it's true or false. It just means there is some truth value that can be assigned to that statement. Okay, we'll call that a proposition. So a proposition is a statement that is either true or false. Let's quickly see a few examples. One possible statement that is true or false would be something like, every real number is positive. Now that is a statement that we can assign a truth value to, and of course you know that there are negative real numbers as well, so that would be an example for a statement that is false. Another possibility that is not so easy to assign a truth value to would be something like, there is an infinite number of primes. Now, again, this is a statement that can either be true or false. There's nothing in between. And maybe you know the answer to that one already. That is a true proposition. But then there may also be propositions that clearly are true or false, but we don't know the answer. Something like, there is an infinite number of prime twins. Prime twin, that's just two consecutive prime numbers. So a prime number p, such that p plus 2, the next possible prime number, because it needs to be odd, is also a prime number. That is called a prime twin pair. And one open question currently is the question of whether there is an infinite or a finite number of prime twins. Obviously, that is a statement that can be true or false. Nothing else. It's either true or it's false, but we don't know the answer yet. And that is not necessary. And of course, these statements do not have to concern numbers. They do not have to be mathematical in any way. Something like, Alice owns a red car. That would also be a statement that can be true or false. Okay, so from these very simple building blocks, we start making up more elaborate statements. And those are usually conceived by connecting several propositions together. Something like both proposition A and proposition B have to be true, or a little more involved, if proposition A is true and proposition B is false, then proposition C must also be true. So this is what we call propositional logic. Let's quickly talk about some possible connections, some truth operators on these propositions that we will often encounter in mathematics. So what we want to do is we want to formulate more elaborate statements. And these more elaborate statements can be formed by connecting propositions. Using what we formally call truth functional operators. The name is not important. What is important is the notation and the idea that is behind that. Okay, let's say we have two propositions. Let's call them A and B. And then we can define connections of those two propositions. So let A and B be propositions. Then what we define is the following. First, we define the so-called AND connection. That is true if and only if both A and B are true. And we abbreviate that by A and this symbol here that is known as the AND symbol. Yeah, so you'd say that is the connection A and B. And that is true if both A and B are true, and it is false otherwise. So that's a new proposition that says both parts of that proposition need to be true. Of course, there's also the kind of the opposite. There's an OR operator that says either that, or maybe both are true, and then that whole proposition is considered true. And that's written in almost the same way. You just flip that symbol around and get something like that. Looks like a V. And this is pronounced A or B. So this is true if A or B or both are true. And it is false otherwise. So this would only be false if both A and B are false. There's one more pretty simple operation. That's the logical negation, written as not A. Or you could also say this is A negated. That is true if A is false. So it's the opposite of A. And it's false if A is true. Yeah? So if you want to express that some condition does not hold, then this is the logical operator you need. And now let's get to two more involved operators that we will often encounter in the statements that we will formulate. What we will, of course, want to formulate are statements like, if this and that condition is satisfied, then this other condition is also satisfied. We want to make deductions. And for those, we need the implication operator. That is written in this way. We have this double arrow here, and that would be pronounced as A implies B. Or if A, then B. Such a statement is true if whenever A is true, B is also true. In particular, whenever A is false, there is no requirement for B. So the whole statement, A implies B, is always true if A is always false. Yeah, that's maybe a little unusual, a little complicated. You have to get your head around that. Okay, so let's write that down first. So this is true if A and B are true, or if A is false, then B doesn't matter. If A is false, that's always true. And it's false if A is true and B is false. Okay, so in other words, what that means is whenever A is true, B must also be true. And whenever A is not true, we don't care about B. Okay? There's a quick notation to express the opposite of that, of course. You can also write something like A is implied by B, like this. You just reverse the arrow. A is implied by B. And that is equivalent to B implies A. So just a conventional shorthand. And finally, one more shorthand. There's the double arrow notation, like this. And you would pronounce that as either A is equivalent to B, or A holds if and only if B. And that is a formulation we will often encounter in our statements, if and only if. And that means both statements are either true at the same time or they are false at the same time. Okay, so this statement, this proposition is true if both A and B are true, or if both A and B are false. And it's false otherwise. Okay, let's see a few examples to conclude that introduction. Let's say we have two statements, or maybe three statements. A is the statement, it is raining. Now, depending on your location and the time that you watch this video, this may either be true or false. It might have a different value for each of you, but for each of you, it clearly has a defined truth value. And the same holds for B. B is the statement, the sky is cloudy. And let's introduce one more statement. That is the statement C. And we call that statement C. We make up something that is false under any circumstances. Let's say something like the moon is pink. That is surely not true. Okay, then what implications hold here? Let's look at a few selected implications. First one we're going to look at is this implication A implies B. Meaning, if it is raining, then the sky is cloudy. And that is usually a true statement, at least I hope it is. So if there is rain, then of course that rain needs to come from clouds. So the sky should actually be cloudy if it is raining. Okay? Of course that depends a little on your definition of rainy and cloudy, but under normal circumstances I would say this is a true statement. If it's raining, then it's always cloudy. If it doesn't rain, we don't really care whether it's cloudy or not. Yeah? If A is false, then B doesn't have to be anything. What about the reverse? B implies A. Is that true? Well, that would be the statement if the sky is cloudy, then it is raining. And most of you know from experience that this is usually not true. A cloudy sky doesn't necessarily mean it has to rain. It could also snow, or there could be no rain or no downpour whatsoever. Okay, so this is usually a false implication. And that also means this equivalence relation, A, if and only if B, that is also not true, right? And in words, this would be the statement, the sky is cloudy if and only if it is raining. Or equivalently, it is raining if and only if the sky is cloudy. That is not true. One direction is correct, but the other is not. So this is a false statement. And let's look at one last implication. Or maybe two last implications. What about A implies C? That means if it is raining, the moon is pink. Well, this statement can be true or not, depending on the value of A. Obviously, C is total rubbish. The moon is never pink. So if it is actually raining, that is a false statement. Yeah, if it's raining, the moon is not pink. And same thing about the reverse. Let's look at that one. C implies A. What about this? Yeah, if the moon is pink, it is raining. Well, the moon is never pink, so C is a false statement. And what does that mean? Well, that means it doesn't really matter what A is. This is always a true statement. Yeah, the moon is never pink, so we don't have to know about the truth value of A. There is no implication here that we need to fulfill. Okay? So this is, in fact, a true statement. So that concludes our little introduction into propositional logic. We often make use of the logic that we've seen here in the statements that we write down later, what we discuss later. So this was meant as a little refresher, a little introduction into this way of speaking, and of course also into the notation. It might seem a little strange at first to formalize this the way we did, but you will get used to that pretty quickly. And of course, we'll work with more precise statements than we did here in the examples. Those will be about mathematics and will hopefully be very well defined, at least in most cases. Okay, I'll see you in one of the upcoming videos. Have a nice day.